All right, everybody, welcome to the video for the Algebra 2 benchmark review. All right, so this is our second benchmark, just like the first one. It's going to be all multiple choice questions. And I want to go through some of the answers here with you. All right, I will also attach the PDF file of this, so if you want to try it again later, or you just want a list of the answers, you don't want to watch the whole video, you can do that too. So number one says to find a solution set of the equation. So one of the things that we learned this year was that with rational expressions, we want to have a common denominator. So the common denominator we're going to have here is going to be x times x plus 3. So if I want to rewrite all three of these fractions with that denominator, the first one I'm going to have to multiply x plus 3 to both the top and bottom. The second one I'm going to have to just multiply x by. And the last fraction I'm going to have to, again, just multiply x by. And then what we did in class was we said, now that all the denominators are the same, the only thing I care about are the numerators. So what I'm circling in red is what I want to eventually solve. So if I do some distributing, 2x plus 6 minus 3x squared equals x squared. I then can start to think about factoring. Now to factor, I have to be equal to 0. So I want to move everything to one side of the equation, and I want to make it so that x squared is positive. So I'm going to move all of these terms to the other side. So that's going to give me 0 equals 4x squared minus 2x minus 6. I notice everything here is a common factor of 2. So I could take that out and get 2x squared minus x minus 3 equals 0. Then we have to try and factor. Now this is where we broke things up a little bit, so we're trying to figure out what multiplies. Whoops. What multiplies to make negative 3, but what adds to make negative 1. So that's going to become, oh, not negative 3, sorry, negative 6. 2 times 3 is 6. So that's going to become negative 3 and positive 2. So when I break that up in the middle, right, so I have 2x squared plus 2x minus 3x minus 3. I then can do some grouping here. And I get two factors of x plus 1 and 2x minus 3, which gives us answers of negative 1 and positive 3/2. The next one says, given the parent function cosine of x, which phrase best describes the transformation obtained to get to cosine of x plus a minus b? So to do this, we're going to go left and down. I know that because this is inside of the function, so it's going to act oppositely. And then minus b is outside of the function, so that's going to act like normal. So we could say choice D here again. Number 7 seems to be on every single Regents exam in some way, shape, or form. It is just the quadratic formula. So remember the quadratic formula. For those of you in Regents, it's on the reference sheet. Those of you in Accelerated need to memorize this. So the first thing I have to do is reorder it. So I have 3x squared plus 2x plus 7. A couple things I could do. Since the choices are some imaginary, some non-imaginary, I could graph this and see what it looks like. If I did that, I'd see it would be a graph that's just floating above the x-axis, meaning it's imaginary. So I already know it's this answer. That's the only one with imaginary solutions. Or I could plug in and say negative 2 plus or minus the square root of 2 squared minus 4 times 3 times 7 all over 2 times 3. I then can figure out what we have there. So this is going to become negative 2 plus or minus the square root of negative 20 all over 6. I could simplify from there to give me negative 1 over 3 plus or minus. This is going to become 2i square roots of 5 over 3. Actually, that's not 20. That's going to be, yeah, 20. No. This would have been 80. looked at my notes wrong. So now when I simplified it, it would have been that. But the big idea here is it has to have I in it. So I know that that's my choice. All right, the next one, if I read through here, the first two choices have biased in it, right? Just the larger store is not a representative sample. 50% of the 90 employees in the food court, well, that's just a sample of people from the food court. That's not good enough. Every employee would not be a sample. That would be the total population. So D would be a good sample. Number 5, which function's graph has a period of 8 and reaches a maximum height of 1? One of the things we remember is we add the midline to the amplitude, right? So the midline to the amplitude, the midline to the amplitude, that gives us the maximum value, right? So if I take -3 plus 4, that gives me a maximum of 1. If I take 5 plus 4, that would give me a maximum of 9. If I was to take -3 plus 4, that would give me a maximum of 1. And if I was to do 5 plus 4, that would give me a maximum of 9. So right away, C and B are not good. They don't even have the right maximum. Don't get involved with the negative. The negative just tells us it opens up or opens down. It's still going to do the same thing for maximum height. Now next it says period of 8. Period, remember, is not in your function. So that means it can't be C. Answer here is A. But to use the period to find the frequency, remember, period times frequency equals 2 pi. Peanut butter equals 2 pi. All right? We'd say 8b equals 2 pi. So b is equal to pi over 4 if I divide by 8 on both sides. Moving right along, number 6. So number 6, there's an equation for the focus and the direction. It's the equation of a parabola, essentially, that we have here, right? So one of the things that we said was x minus h squared equals 4p times y minus k, where h and k are your vertex. Well, it gives us enough information to find the vertex and to find p. We just have to plug it in and solve. So if I graph this, so here's my x and y axis. 0.12 is here. Y equals -2 is here. The point that would be right in between them, right, would be a vertex of 1, 0. That would be 2 here and 2 here. The p-value would be 2 because that's the distance between the focus and the vertex. Notice this is a parabola that opens up because the focus always has to be inside of the parabola. So right away I'd be able to cross off anything that was a negative number, but they're all positive, so they all open up. The other thing we have to see is that we're moving to the right, so in your equation we're going to have a negative number, so it's not going to be either of these two. So really my only focus left is what is that number in front of the x minus 1 squared. So if I plug in everything I know, right, so I know the x value of the vertex is 1, the p value is 2, so 4 times 2, that's 8. And then I just have 8y because it's y minus 0. Now, I don't have these equations solved for 8y. I have them solved for y. So I have to divide by 8. Divide by 8 is the same thing as multiply by an 8. So that's why it's D. Number 7 says there's 440 students at the high school. On the April report card, student grades are normally distributed. So as soon as I see this, I'm thinking normal CDF or Z-scores. Mean of 79, standard deviation of 7. Students who earn a grade less than or equal to 64.9 must attend summer school. The number of students who must attend summer school is closest to what? So let's find the z-score. So to find the z-score here, we're going to say 64.9 minus 79 divided by 7. Whatever that number comes out to be, we'll either try and change it to a fraction or at least get a good decimal here. All right, so we have 64.9 minus 79 divided by 7 is a little bit more than -2, so -2.014. Now, I want to know the students that have to attend summer school. So that would be the people below this number. So if I take my normal CDF and find the percentage that's between -2.014 and goes down to -10, if I normal CDF those two numbers as my lower number and upper number, we wind up getting an answer here of about 22%. Sorry, 10%. I typed it in wrong. So we want getting about 10% of my data falls below that number. Sorry, that's not your percentage either. So this percentage, when you type it in your calculator, is approximately 3%. So it's like 2 point something. So whatever that 2 point something is, you're going to multiply by 440. That's where the 10 comes from. Okay. Number 8 is a really easy question if you know how to use the calculator. We have y1 and we have y2. Plug in y1, plug in y2, and see where they intersect. You're going to get a nice log graph that looks like this, and you're going to get this crazy looking graph that looks something like this. They're going to intersect twice at these 2 points. Remember, use the intersect button in your calculator. Okay? Number 9, Brian deposits 1 cent, and every single day he goes up an additional times 3. So this is a geometric sequence. It says what will be the total amount of money in the account at the end of the 20th day if the pattern continued. So you could either use a summation symbol here, or you can use the sum formula or the series formula. So if I was to use the summation formula, starting at x equals 1, I'm going up to the 20th day. I'm starting with 1 cent. I'm multiplying by 3 each time and going up to n minus 1. Plug that in, and you get choice B. If you don't change it to 1 cent, you leave it as 1, you get choice D by accident. Number 10, we're changing something here that's in terms of years, and we want to make it days. To make the exponent days, we multiply years by 365, meaning it can't be C and it can't be A. And if I do that on the outside, I have to balance it on the inside, so the only answer here that makes sense is D. This is dividing and multiplying. That's 2 different things. Number 11 says, consider the function and the graph below. Which statement is true? Right? So the graph below of m of x has 2 real solutions. If I was to graph p of x, in my calculator, it winds up having 3 real solutions because it has 3 x-intercepts. So the only statement here that makes sense is choice A. And the last question we've done before. It was even on quizzes and such. So what you have to do is find your totals here, 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 and down, down, down. And you can figure out that there are a certain amount of people that fit this given probability. So it says the probability a person texts over 50 messages per month given the person's between 23 and 60. So if you're between 23 and 60, we only care about this part of the chart. So I have 229 people in that part of the chart, and it looks like 157 of them send that many text messages. Thanks, and have a great night.